Geometry, we are in lesson 6, connecting similarity and transformations. Let's start out with our 6.1, dilation miscalculation. What's wrong with this dilation? Why is GFE not a dilation of ADCB? Just glancing at everything, it appears to me that all your angles are right angles, so they are all equal, which that should be correct with a dilation. But if we just look at the side lengths, we're not proportional just from glancing at them. So they're not in the same proportion. We could measure each one and show that if they are dilating, they should be dilating in the same proportion. As another example, it appears to me that these two are pretty close to congruent, yet these two segments have increased in shape. They've dilated. So, I mean, just from glancing at it, that appears to me what is the problem. The angles are correct, but the side lengths are not in the same proportion. They need to use the same scale factor on all four sides. All right, 6.2, card sort, not so rigid transformations. Your teacher, that's me, will give you a set of cards. Please check the side table for your set of cards. So right here, oh, sorry, wrong pen. Check the side table. I've got a set for everyone. So grab one stack of cards. Sort the cards into categories of your choosing. Be prepared to explain the meaning of your categories. So here, I'm going to check your email. You are going to check your email. And if you look at number 2, your teacher will assign you one card. Write the sequence of transformations to take one figure to the other. So again, email. So on an email that you're going to receive from me, I would like you to do question number 1. Go ahead and give me some feedback. And question number 2, you're going to have the one card that I assign you. So reply back to that same email, the one email, and answer number 1 and number 2. Cool? So I should receive an email from every student sometime tomorrow. So number 3, for all the cards that could include a dilation, what scale factor is used to go from figure F to figure G? What scale factor is used to go from figure G to figure F? We're going to do that on the next page. Okay, so for card 1, let's do this. So we're going to go from, I believe it said F to G first, and then G to F. So for card 1, if you do those measurements and you check it out, from F to G, we're at 2/3, and then from G to F, we're 3/2. That's our scale factor. For card 2, F to G is 1/4, and then G to F is 4. Card 4, F to G is 1, and G to F is, hey, 1. Card 5, F to G is 3/4, and G to F is 4/3. Then card 6, we are the same, 1 to 1. What do you notice about all these? From here to here, there to there, well, there to there, we are reciprocals. That's a hard one to spell. Reciprocal. Okay, that's the flip of the fraction, okay? You flip the fraction over. All right, so that is the card sort. So again, to refresh your memory, I need a reply to my email with an answer to number 1 and number 2 from questions 6.2, the card sort. Okay, looking at alphabet soup. You guys ever had alphabet soup, like Campbell's alphabet soup? Yeah, I didn't like it either, but that's all right. So we are going to add a definition to your reference chart. I'm going to write that on the next page, but here's my reminder. We're going to add a definition to that reference chart that you have at the front of your binder. I'll put that on the next page when I'm done with this. So for this problem, are the triangles similar? If we look here, we see that, let me get my highlighter out. AB is parallel to QR, so AB is parallel to QR, and AB is perpendicular to AE, and QR is perpendicular to QT. So that means I have a 90-degree angle here and a 90-degree angle there. And when these are parallel, yeah, well, all right. Write a sequence of transformations, dilation, translation, rotation, reflection, to take one triangle to the other. So we're going to answer number 1. Need my pen back out. There's lots of different answers here, but I could start out with translating figure ABE by the directed line segment A to Q. Let's see, I'm going to go A to Q. So translate ABE from that, I'm going to say ray, A to Q. On ray A Q. I guess I don't need the word ray and the figure ray. So I'm going to translate. Then I'm going to dilate triangle or figure ABE using center A and a scale factor. What would that scale factor be? Let's see. I know I need to go smaller, so I'm going to go ahead and do 6 divided by 15. Get my calculator out. 6 divided by 15. I have 0.4. So my scale factor is going to be 0.4. So that is my sequence of transformations to take triangle ABE onto triangle QRT. I'm going to go ahead and check the other proportions, make sure they're good. 6.8 divided by 17. What should I get for that? 0.4. And I do. I get 0.4. I'm going to go ahead and check 3.2 over 8 and get 0.4 again. So all of my sides are good. So, okay, side, similarity checks out. Okay. Okay, I need a new page to work on number 2. Number 2, write a similarity statement about the two figures and explain how you know they are similar. We can say, I just did it a little bit, but we'll write it out. ABE is similar to QRT, or we could say BEA. Lots of different ways we could say it, right? BEA is similar to RTQ. And this is number 2. The figures are similar because a sequence of rigid motions and dilations, which are not rigid, takes one to the other. We can also say the side of ABE is proportional to the side of QRT. All right, number 3, the question is, compare your statement with your partner's statement. Is there more than one correct way to write a similarity statement? Is there a wrong way to write a similarity statement? Yes, there are many ways to write the similarity statement. We just need the corresponding parts to match. So yes, there is a right way, and yes, there's wrong way. Like, I can't say that ABE is similar to RTQ because those aren't corresponding parts. The parts aren't corresponding. All right, like I said, check your email. It was a short lesson, but I need you to respond, okay?